The University of Kentucky Nursery Landscape Integrated Pest Management, UKNL IPM, interviews are sponsored by a grant from the University of Kentucky Integrated Pest Management Program. The interviews cover plant production, pests, and shared information from industry leaders. This edition is an interview with Dr. Jim Owen, who at the time was Associate Professor of Plant and Environmental Science at Virginia Tech's Hampton Roads Research and Education Center. Jim's research and extension programs focus on enhanced management of resources in commercial nursery crop production to increase profitability while mitigating environmental impact. Since this recording, Jim now works for the USDA at Worcester, Ohio in application technology research as a research horticulturist with the same mission. We're here with Jim Owen, Dr. Jim Owen, who is a professor at Virginia Tech, housed at Hampton Roads. Is that what they call it, Jim?
The Hampton Roads Ag and Research Extension Center, yes.
All right. And he teaches class there and works as the nursery specialist for the area. And most of you know, in that Hampton Roads area, we have two of the biggest nurseries in the country that produce plants in containers, Bennett's and Lancaster Farm. They're both still there, right?
Correct. And we have the Eastern Shore Nurseries.
Oh, that's right. I forgot.
That are sending stuff up north as well.
It's a fairly significant area of nursery production. And we're going to ask Jim about what the impacts of water management and nutrient management and substrate management are on growing plants. One of the things that he spoke about today at the KNLA Winter Conference was specifically about managing plants that you receive from these wholesale nurseries at your garden center or redistribution center and paying close attention to the status of those plants, whether they have fertilizer or any of the other things. So, Jim, if you could kind of recount just briefly some of the things that you were talking about today relative to plants in the retail environment.
Sure. So the retail environment is not my specialty, but I usually work in large production nurseries where things are on acres basis, not in square feet or yards basis. But for retail, they have a unique set of problems in that they are usually adapting old systems to expand or trying to fix what they have. So they have a hard choice between how they're going to apply that water. And so they need to look at different methods, from overhead irrigation for holding yards, for containers 1 through 5 gallons, 5 gallons up or 7 gallons up using micro irrigation. And then there's some unique opportunities, I think, for them in the retail setting where they can use sub-irrigation ebb and flow benches or capillary mats, both with some drawbacks, but able to water throughout the day, but able to do that. I think one of the other things is I was surprised today not to see many people raise their hands about checking fertility of crops they're bringing in. And almost no one was shifting up their plants as they came in. So I think that there's a real opportunity for education there that root-bound plants are not going to, they're going to go into decline potentially. And if there's no fertilizer there, you're going to have more problems.
Sure.
So these should be using techniques we use in the nursery trade, such as the pour-through method to look at pH and EC of your substrate solution to deal with that, as well as your water quality. I had some blank faces out there today when I was talking about water quality, some very knowing faces as well, but alkalinity versus pH, the ability to acidify your water. These are, I think, small investments in the long run to ensure success of that center where so much goes into the layout of the center, but maybe it's nothing behind the scenes is really going into thought about you're still producing plants. Sorry.
Well, we, as we were thinking about this, I guess a first-class relationship with your supplier would be a primary in that they can give you some indication to be looking at when your materials come in and what you can expect. But we do see that decline even in our own research where we've held plants too long, and now we are supposed to be using them in research, and we have to make the decision to spend more money to bottom up and bump them up and check the root systems and see where we're at and whether they're even of a quality that we should move up. So sometimes they've declined enough and the soils are wet enough, when you pull them out of the pot, the bottom of the soil ball falls off. Well, that's obviously been in the pot too long, and I don't know, do you see that with hydrangeas and some of the other plants?
Hydrangeas are one of the worst, but usually that happens in production. I didn't know that it could happen, but there is root sloughing, especially through the winter. But I call it pancake root, and that's where you can supply the nutrients and everything that the plant needs in the top inch or 2 or 4 inches of the container, and you make the rest of it anaerobic because you're trying to keep that plug happy, and you end up overwatering the system so much. But it's basically growing on nutrient film technique almost, or it's being hydroponically grown so that there's no reason for those roots to go down and explore the non-optimal area where it's gotten too wet. I also thought it was really interesting you brought up the liner source. It would be interesting to see how much shrink people have when they're not controlling their quality of plants they're buying into the retail and holding yards. Sure. As you were talking about earlier before we started, was that people are willing to pay a premium, those retailers, if they know what they get and it's consistent and they can hold it, versus shrink where people are buying from multiple sources and not knowing their liner.
Yeah, well, that originally came to me. I went to visit Martyrs in East Hampton, Long Island, where they had a master's level horticulturist doing the watering and deadheading of the plants so they always looked nice. And I thought, that's quite an investment. But of course, they have a very high-end clientele. But even in a place where your clientele does not match Martha Stewart and others like that, if you get in good plants, then you have less of this decline. In Western Kentucky, when we're on wells, you run into so many different problems that are unexpected. Salts, how did that happen? When we got all these lakes and all this water, where is the salt coming from? When you were talking today about testing, let's just run through quickly water testing for your source material, whether it's city water or whoever, everything varies.
Right. Basically, your cooperative extension agents can usually test your water. There's also a number of commercial labs throughout the United States that you can send your water quality to. My biggest recommendation is choose one and stick with it so that the data is the same and means the same thing. Also know that the recommendations are guidelines and not exact, and that you may want to refer to other references to see where those numbers are and if they're adequate or not adequate. But basically, you're testing your water for pH, alkalinity, hardness, iron, sodium, chlorine are some of the major ones. There's also quick tests you can use on site for if you're chlorinating your system. You can have a pH and EC meter to see your salt levels. But alkalinity is one of the big reasons you want to be testing an iron if you're seeing issues, because it can give you an idea, and then you can talk to professionals or your extension agent specialist to see how you should treat it.
Sure. We see everything, you and I, from our tours and travels, from inline systems, very expensive, high-end systems to control those things with injection and everything else, all the way down to somebody using a stick to at least try to monitor and maintain what's going on with their plant material. And of course, we have outstanding growers from the biggest to the smallest, and we have awful growers from the biggest to the smallest. So
well
you do want to be sure your source, where your material is coming from. Could you speak a little? We mentioned earlier some of the aids that are available, like some of Paul Fisher's work down in Florida with the greenhouses, some of the work that you and Anthony Laboud, Dr. Anthony Laboud at North Carolina have done with the clean water program and the grant process. Could you just mention some of those aids that are available to people?
Yeah, so cleanwater3.org is a website that you can go to. Paul Fisher runs it. It's also part of the Water Alliance. And that is an output or clearinghouse for information from the SCRI, Specialty Crops Research Initiative, that was funded by the USDA. 4 years. This is our final year we're going on it. And we've been looking at how to remediate, recycle, and it's not reuse. I can't think of the third term. That's funny since I'm on the grant. But
three R's.
The 3 R's. But anyway, it's a clearinghouse from everything about water quality interpreter, where you can enter your data. We posted our Grow Zone tracker on there, as well as through eGrow, which is Brian Whipker's site, which allows you to use Google Maps to track pH and water pour-through data and water quality data, and have locations and map it real time and get real-time feedback as well. On that clean water, going back to the Clean Water 3 org site, That's a really nice site because it has case studies, it has the presentations that we've been giving, the references, as well as Paul's done a really nice job of having sections on water treatment, ponds, how to deal with water before it goes back to your reservoirs, on and on, that you can go and learn about that. And it really is this nice integrated singular spot to go to that connects Water Alliance with the Clean Water 3 group, which is, I think, 15 scientists in that group. And then the Water Alliance is another 10 or 15 people, and all of that's culminated on that website.
Sure, and that group, NC 1186, also had, and SNPM for the Southern Nursery IPM, have all worked on this together over the years, sensor monitoring, and that was cleanwater3.org, and that's just, like it says, CLEANWATER 3, the number 3.org. So check that out because there is some outstanding information there. And you can get on their potential email list, and Paul Fisher or Jim or someone else is doing a webinar related to the activities. You'll get an announcement of it and be able to participate in that. So Jim, I promised myself someday I would stop saying so, and I haven't. But in any case,
I say
so. Some of the what is your primary area of research, and what are you excited the most about what you're doing with your students and yourself?
So mine, I look at the intersection, in grant terms, the nexus of water, substrates, and fertilizer in the container, the edaphic environment or rooting environment, and what that does physiologically to the plant. And we always used to look at maximum growth, but maybe we should be looking at optimal growth as we move to shipping on carts and other things. So I really am interested in optimizing resources so that we use them and that we can still be the green industry, be the environmental stewards that we all want to be, while still being very profitable at using those resources we apply. So my most interesting thing right now, well, we're finished up a project with Jake Schreckheis, who's now at USDA as a plant physiologist, who I spoke for here today. And that was, we really feel like we finally have a handle on phosphorus and that we can lower the phosphorus and CRF formulations. And we also understand where phosphorus goes for the first time, that your lime and micronutrients are really impacting it. We also have been working with Clean Water 3 on understanding agrochemical fate, including pesticides, with Tom Fernandez at Michigan State. And I think that's going to be some telling research that shows that maybe the herbicides we're applying pre-emerge may not be quite as efficient or staying where we want them to stay as much as we thought. So we're looking forward to that data. Damon Abdi is the PhD student doing that work. The future I'm looking at with James Altland, Chris Marble, and Jeb Fields. Chris Marble's at University of Florida. Jeb Fields now at Louisiana State University, and my past student, and James Altland's at USDRS, is we're looking at re-engineering soil to substrates. So I think the neatest thing that we've been looking at is if you take the container and think of it that we have a unique ability to modify that substrate how we want. So we can potentially put fine substrate on the top for the transplants over coarse substrate, hopefully to defy gravity basically, and not have these pancake plants, not have these regions. Also, through Tyler Hoskins' research in our lab, we realized that through solute transport models and all of this, the substrate physics, let's say, that we may be wasting a large portion of fertilizer in that we incorporate in the bottom of that container. And incorporation reacts different than top dress fertilizer. So we think there may be an opportunity to placing that fertilizer in different profiles, banding it, or just incorporating in the top half. And we can see that we think there's a potential to reduce fertilizer by 25%, at least. And control of these fertilizers, no cheap addition to your system. Sure. So that's kind of the real exciting project. The only other thing we have is that we're looking on is now we figured out phosphorus. We really want to move on to nitrogen. Lauren Oakey's already got a good start on this with Bruno out in UC Davis. But since we're on the East Coast, there's still lots of opportunities. Where does all the nitrogen go? And the other thing is the papers don't look at urea, and we apply urea. We just got analytical capabilities to look at urea, nitrate, and ammonium, all three. And we're getting some really interesting data. That's preliminary. But we hope to have a PhD student soon begin looking at the gaseous as well as the liquid form and the biological forms of where does all this nitrogen go in the container so that we can do that, and then look at management practices where we put fertilizer, how we irrigate, what kind of substrates are we using, and start to incorporate that into change once we understand the basic mechanism.
For those listening, I might say that we've been working on research since we put the first soils in metal cans.
That's right.
Vegetable cans from restaurants and things back in the 60s, and still have numerous problems at many large nurseries on defining what will work best for a specific plant or a specific site or a specific environment or a specific type of water, or we only have this media available. I'm going to put you on the spot. I've seen rice hulls, used for weed control, and I've seen them used at a depth of up to 2 inches on the top of like a 7-gallon pot. Do you have any ideas on what the impact of that's going to be?
I can't really answer that question, but people are really excited about rice hulls, and the guys that are weed scientists, the Chris Marbles and James Altlands of the world, are big proponents of it. And it's now also being used as a substrate component, I understand, successfully, which I was very concerned about it living long in the pot because it would decompose. But I hear very large, successful nurseries using it to incorporate to reduce their costs.
Ammons here in Kentucky has used rice hulls and, of course, mushroom compost and other things in the past. We bought our first Riceland rice hulls this year to incorporate with a study we're doing on hog, chicken, composted hemp, cattle manure composts. We'll wait and see how it works out. As I think I told you already, we found that mixing in these types of hot composts does give you an initial charge, which we normally need in production to get the plants going and keep them green and not have them yellow out and then have to catch up. And sometimes they don't catch up if you're short of nutrients. So there's so many interacted things that impact how we grow plants in containers and in the field too, for that matter, soil type and all the other things. Well, Jim, I'm excited that you took the time to join me today, and we've had another one of the Clean Water 3 on this broadcast with John Lee Cox, and we'll be chasing around to find Amy Fulcher and Tom Fernandez and others as time goes on. Jim and John, Wayne Lovelace of Forest Keeling will be the first 3 or 4 on this, and I thank you very much for listening.
All right, thank you.